In this Industrial Academy tutorial, I will explain how can we convert a 3D sketch to a 3D pipe in Autodesk Inventor of required spec and size. The question is why we need to convert a 3D sketch to 3D pipe instead of direct modeling. The answer is very simple and justified, as we know that different types of industries such as the chemical, food and textile use different types of spec and sizes of piping. To model these different types of pipes, one needs complete information of dimension, geometry, material code and a lot of more regarding to desired spec. To address this problem, tube and pipe option has been developed in Autodesk Inventor to facilitate greater flexibility, speed and ease of 3D modeling of pipes and tube. Tube and pipe option provide inbuilt libraries of almost all spec and catalog of pipes and fittings used by various types of industries. One need not a complex and tedious information regarding to the spec and other information. Let us start and convert a 3D sketch to 3D pipe. For this, open new assembly in Autodesk Inventor. Create new part. Start 3D sketch. Here we draw a 3D sketch. Let we take it 20 inches. Here we have finished 3D sketching. Return to assembly mode from part mode. In assembly mode, go to environment tab and here tube and pipe is saying that we have to save before proceeding. Click OK and give name anyone that you want. Click save. OK. It is saving. As we will convert this 3D sketch to 3D pipe, for this Inventor is asking name of runs file. Give any name that you want. Suppose we select same. Press OK. Here we can see that run 01 has been created along with necessary ingredients needed to run the pipe from 3D sketch. Now we have to tell the path of 3D sketch for which pipe and tube run 01 has been created. For this, select new route. As it is not existing one, click on new route. Give the name of the new route file as you want. Let we take it same. Press OK. Here we can see that route 01 has been created. Now we have to tell the derived route for route 01. Click on derived route. Select the sketch. Here we can see that derived route 01 cannot be created for route 01 and end up with the error. Reporting error is violation exists on route 01, minimum length violation. Okay, what are the reason of this error, or how can we handle this error in 3D pipe modeling from 3D sketch? This is one of the most common error in the pipe and tube section. What are the causes of this error? One cause is improper 3D sketch. First one may be due to the constraint, that constraints are not properly applied to the lines of the sketch. Second one, pipe and tube will only work when the lines of the sketch are perpendicular. If the lines are not perpendicular, then tube and pipe sketch will not work and it will give error violation exists on route 01. Another cause is improper length of line segment of 3D sketch. Let I explain. Open tube and pipe style. Here we can see a tab of rules where it recommends the minimum length of route, maximum length of route and increment. Here we can see that it has been automatically selected by the inventor according to spec, minimum length and other. If the line segment length has mismatch to these rules, minimum, maximum and increment length, then there can also occur. But in our case, it does not seem to be the cause of the error because we can see that it has led to reasonable minimum, maximum and increment. We can edit these values. Click on the select spec and edit, and here we can change minimum length, that is 1 inch, similarly maximum length and increment 0.2 inches. These values should be according to your sketch and a perfect match should exist between your sketch and these values. Suppose if we have a line segment of 1 inch, here we select minimum length 2 inches, 4 inches and increment 3 inches, then the error will be common and your route will be not performed. Let me close it. He is saying to save the error, but we do not want to save the errors. The other reason may be due to fitting dimension and sketch dimension mismatch. Suppose we select a sketch 2 inch in X direction and 2 inch in Y direction and apply it to a 2 inch pipe of any spec. Here we should consider that your selected or drawn segment length should provide radial length for elbow, T and other fittings. I will explain this error at the end of video by example. Let in our case, the minimum length violation error is due to the improper sketch. Let we draw a sketch again and route tube and pipe. Finish pipe routing. Click on sketch, delete sketch. Also finish tube and pipe and leave tube and pipe run. Create new part. Here I will draw the same sketch of same dimensions in proper way. That we take it 20 inches as in previous one, and in y direction we take it 30 inches, and in this direction we will take it 38 inches, and in this direction we will take it 40 inches, and press OK. Here you can see that the same sketch of same dimension has been drawn properly. Finish sketch. Return to assembly mode. Go to the environment tab, tube and pipe. Again, run tube and pipe. Go to the new route. Select name if you want to change it, and here change spec if you want. This is our activator spec. Click on it if you want to activate this. Click activate tab. We want not to change. We can edit by selecting edit. Here you can change diameter, schedule, outer and material, and many more. Here we can see minimum length, maximum, and other rules that has been selected to route pipe. Let me select now drive route and select the sketch. Press done. Here you can see that now you can see that for the same sketch and same dimensions, a route point has been created. Now finish route and click on populate route. You can see that sketch has been converted to 3D pipe of our desired spec. Let me change it again. Go to back and to pipe style. Let me change it to this Japanese industrial standard. Select threaded. Running that you want. Activate and close it. You can see that this standard, thread standard, has been applied. Here we can see that spec is not changing, although it is changing above. To change it, we have to reverse it. Again, go back. And select new route. Before this, you should before no routing, you should select French or any other desired spec, activate it, close, and here we can see that new route has been created, route 03, drive route, and finish route. Select the route that we want to populate. We select route 03. Here we can see that then standard spec has been populated and come here as compared to the previous one which not come here. Every time we have to create new route, that will take other examples. Go back and create new route 041 and here go back again and first select spec. Let me select some screen type, activate it, edit if you want to change diameter, schedule and other things. New route, route 04, drive route, finish sketch, populate route and select route. We have to select route 04, ASTMA 53, press OK. Here we can see that desired spec has been performed for our 3D sketch. We can see that the given spec has been applied to the 3D sketch. Let me again change it, perform new route 005, and first we have to select it. That way here in this activated these standards, tailor pipes, new route 005. Sketch, upload. We can see that this standard has been applied to given piping system. Let we again go back and change another. First, style. ISO, activate, from new route, go to drive route, done, and finish route, populate sketch, steps route 01, 06. We can see that standard spec of ISO has been applied with long radius elbow. Let me change the size of the same step. Go to the edit and select. Let me select maximum size in the spec. New schedule is selected according to the pipe diameter. If you want to change the color or material, we can change. He is performing size change. You can see that 1.5 inch has been converted to 2 inch pipe size. Let me change another spec. And go to this radial steel and pipe, activate it. New route 007, okay. Deselect piping. seems that something. Let me delete this out and select some other. Let me select this welded pipe and fittings. Perform new route, Auto 7. Spec Auto 7. Okay. Here you can see that new type of spec has been applied. Let we change the size. Let we change size from 3.5 inches. Yeah. See. Here you can see that it has been changed to 3.5 inches. Similarly, we choose some spec in which we route a pipe, let's say, of larger size, 24 inches, 36 inches. Then the radius of the elbow and D should be considered. If these length of line segment and rule and the radius of elbow are mismatched, then it will give error and could not perform pipe routing according to your sketch. Then you have to change the length or increase the length of the lines. One thing has been unclear, that you can create part in assembly or you can create sketch in separate IPT file and then open in assembly, and then you can perform pipe routing with IPT sketch file. Thanks.